Yes. So we are at the final step, or not final step, one step where we need to configure incremental load in our Spark notebook. So the final step in our data transformation, in the process of our data transformation, was writing the final data frame, which you can see here, to our lakehouse database as a clean delta table. That's what we can see here. So, but what happens now? Like, if I go ahead and try to rerun this final step, and I'll give you a guess, or I'll give you the answer, it will show us an error. But what error? So let me run this so you can see. Let it run, let it run. Yes. So we can see an error. Cannot create a table or view in Bing Lake database because the TBL latest news already exists. So what's going on here is that because the table already exists, unfortunately, we cannot write a code. We cannot like run the code to create this same table in the same lakehouse because a name like that already exists. In this kind of case, we can give it a different name. We can, as you can see, drop or replace existing objects, or if not exist clause to tolerate pre-existing objects. But this is not what we're not going to follow this default methods all the way here. We're going to solve this problem in a way different way. In a way different way. Yeah. So what way am I talking about? I say we're going to go solve this problem in a different way. I mean, there are about 3 ways to solve this problem. Just looking at this, we can actually okay, we can actually go ahead and do this. Okay, we can override the entire database to the same delta table. I'll show you what I mean. So I can say, okay, let's override this data. So basically, our whatever code you run on top, whatever is the product of the df clean final, if you run this code again, we can make it in a way that this the new df clean final, if anything happens in terms of our data ingestion and things like that, it's still save as this maybe our latest news, but it overrides the previous information all the way there. So I'm going to edit this code in a way that will overwrite our data. So df clean final delta dot mode. And instead of dot save as table, before then I'll say dot mode. And what kind of mode am I going to give it? I'm going to give it an override mode. Override. So yes, dot mode override. Dot mode override. We can go ahead and override the data. So let me run this. Oops, excuse me for that error. I put double E instead of one. So it's running, let it run, let it run. Let's X this. While it's running, a major question is this actually the best way to go about insert data? Because like what there's a lot of processes here, data ingestion, data transformation. The question is overwriting the former data with the new one the best way to go about this end-to-end data engineering project? The answer is no. And why is it not the best way? The thing is that using this override mode, like making the df cleaned, maybe a new result happens, or maybe the ingestion process will refresh and things like that. Like override changing the current data entirely with the new data is not really the best way because it can bring performance issues. Why? The data already exists. So in a way, there's no point to override the same data to the table because this will waste additional time. And actually, it could actually get worse if you're working in real time. If you're working on a real time data project that's maybe in petabytes or terabytes, it could actually get worse. Performance issues will be very slow, things like that. Another reason is that there's a high possibility, there's a high chance that you can lose the data that you have worked. E.g., maybe you have an example now. Maybe you have the latest news for today's date in the table, and if you go ahead and rerun this, entire code tomorrow, like from the top to the bottom, tomorrow, it gives you new data for that same day, or for that day, which is tomorrow, hypothetically. So what this means is that your previous data basically gets changed and overwritten, and we don't want this. So we don't want a situation like this. So because of these reasons I've mentioned, we will go ahead not to use this method. So I remember saying we have about three methods that we can go about um, making sure that there's not an error when we save. There's the override mode. The second solution is using the append mode instead of the override mode. So if we use the append mode, instead of the data getting overwritten, so I'll just literally to do this, I'll just say mode append. So instead of the data getting overwritten here, it gets appended, it gets added to the table every time I run the step. So imagine I start this Spark Notebook data transformation process, all over again. If the data was refreshed from the API or whatever, if you got like a new data, basically what happens in the append mode is that the new data is added to the previous data. And the funny part is if the data is also not new, this because we chose append mode, whatever results in DF claimed that with me running it again, like maybe I've run this the second, I've already run it the first time, I have my results. But if I run it again, whatever result it is, whether it's the same or not, also gets appended. So I will show an example. So in this my example, I'm just gonna write just some SQL code. So I'll write some SQL code over here. So let's start it out. Percentage SQL. And I will say select count all. Select count all. That's count star from Bing Lake. So let's query this database basically. Sorry, excuse me, from Bing Lake TV. Okay, when Bing Lake TV is new. So let's query that table. And when I say select count all, what will you see? See what we can see. Yes, we have about 51 rows of data, basically, which is quite cool. I mean, it's normal. This is what I was already aware of this. But let me go ahead and rerun this and see what happens now if I run this again. So I'm going to rerun this step, append, and I'm going to count all again. Let me see whether it still remains 51 or maybe is 102. So yes, now it's 102. So I don't know if you can see kind of the reason why I'm not going with the decision for the append mode. Because now I didn't even rerun the transformation step, and imagine I did, and maybe I get the same answer. But like I didn't run the transformation step, and basically the same data was appended to the previous to this table. So it already had the 51 rows of data, and because I ran this process with the append mode, it knew 51 rows that are still there, that is still the result of my data transformation step, is added again. And this is duplicate data. It doesn't make sense to be having unnecessary duplicates in our work. Yes. So it doesn't make sense at all. It doesn't make sense at all. You can lead to multiple duplicate files in our table, you know, and it could lead to performance issues actually. In the case where the volume of data might increase, like you're just increasing the data volume unnecessarily. And this is just a smaller project. Imagine it was a larger project. You're just adding duplicates and increasing the volume, increasing the storage, like it doesn't make sense. So this will not go ahead with the append mode because of this. And I will actually use a different method to configure the incremental load. So I'll use a third method I've not mentioned yet, but I'll mention it now to go ahead with this incremental load in our project. But yeah, what do I mean by incremental load? I don't think I've made that knowledge space. I've not defined it. So in our case, in this example we're talking about, like we already have a data stored in our lakehouse database in a table format. We know that. What we want is that we want a new, like, what we want is that as a new data comes, or it's processed or transformed in our Spark notebook, it will be saved in our data table if we run any chunk of code to do that. And if the data does not already exist in the delta table. So what am I saying is that basically what we want is whatever, if we run this step and whatever, it's kind of similar to the append mode, but like it only appends, or let's say data, new data is only added to the table which exists if that um new data doesn't exist. So basically what I'm saying is that if we run this and there's a duplicate data, the duplicate data is not added to our current table. So we don't want to be adding duplicate data. We only want to add data to our table if that data does not exist. If that data does not exist, I think that's what I'm going for in this case. So yes, basically the process of selectively loading new data in our table, in our delta table, is what we call incremental load. Incremental load. So I think the next question from here is how can we actually go ahead and perform this incremental load? So we're going to do this. It's a very simple answer for me, at least. We're going to do this incremental load configuration and whatnot, making use of the SQL merge data warehousing concept, or SQL merge data warehousing. And of course, at least from my knowledge, SQL merge is done in about two ways in data warehousing, and there's type one slowly changing dimension and the type 2 slowly change dimension. So the thing is, what's an easy definition? What easy definition can I give for type 1 slowly changing dimension? Basically, in type 1 slowly changing dimensions, if you don't want to preserve history in your table, and you just want to keep the latest record in your table, you make use of type 1 slowly changing dimensions. If you want, and for type 2 slowly changing dimensions, if whatever you are doing, you want there to be a history of the previous data that was there. Like you want to know what was there before and what is there now. We want to preserve the history in our table, and we also want to keep the latest record. We'll use type 2 slowly changing dimension. So of course, now the question to ask, or the question to ask at this step of our process is, what method are we going to use in this our case? So when we run this, and if it checks, when we run this df clean find out, well, I'm going to edit this code, but basically what I want is when we run this code, let's say the previous one before this mode, so let's put save as table. So save as table. When we run this code now, what we want is that, of course, new data is only going to be added to the table if it doesn't exist, in a way, if it doesn't exist. But I think that's, but when we run this what I want, excuse me, what I want is that I don't want to keep the history of what was previously there. I don't want to keep previous history. So we'll make use of type 1 switching dimensions. And I will tell you why. Because our project is focused on creating reports that give us information about the latest news. We are not actually interested in having any version of the same news in our table. I don't think that's very necessary. So also, I think it's very unlikely that once a news is published on the big API, the maybe the type of the news or category, things like URL or description, or maybe any other property, I don't think it will be updated with the news article. So yes, I think these 2 points, the fact that we're not interested in having any version of the same table in the same news in our table, and the fact that it's unlikely that news properties may be updated from your table. I think these 2 points are the reason why I'm going to choose working with the type 1 slowly changing dimensions, or these are for performing incremental load in our project. So yes, I think from now we should go ahead and implement this incremental load in the way we are talking about. So of course, I've edited the mode back to the previous mode it was before, and I'm going to run this again. Of course, I know there's going to be an error. I'm going to run this again. So yes, as I was saying, I went ahead and ran the code, and you can see an error all the way here in our code. So, but like, what kind of error? Well, I mean, we know the error happens because the table already exists. And yeah, what we're going to be looking at now is what's going on here. Analysis exception. The type of exception it is, excuse me. It's an analysis exception. And we'll be handling the analysis exception, and we're going to be implementing the type 1 merge logic that were, type 1 slowly change dimension stuff that I talked about. We're going to handle the exception, and we're going to implement that type 1 slowly changing dimension merge logic here. So yeah, to start the process of what I'm talking about, I think we should go ahead and delete this TB latest news from our Lakehouse database. So I'm just going to click on this three dots, and it's painful, but I'll go ahead and delete it. So delete is permanently delete. Of course, we are okay with that. Are we okay with that? Yeah, I think I'm okay with that. So I'll click on delete. Okay, successfully deleted. So we have nothing in our table. Amazing, right? So this can't even work. Yeah, did that. Now, yes, in a new code cell, which is that one, I'll just paste a set of code. I'll just paste a set of code I have somewhere. Paste. And this code I just pasted here is what's going to help us implement this type 1 merge. That's what's going to help us implement the type 1 merge. So yeah, I'm just going to make a slight edit to this code. Just a slight edit. Then I'll go on and explain what this code does. So yes, this is actually the what's it called? The code that's going to help us out to be able to properly implement this incremental load that we've been talking about in our project. Yeah, this is the code that's going to help us out. And let's talk about it actually. Let's talk about what's happening, what's going on in this code. So yeah, the code is for managing our Delta Lake table in PySpark. The goal is to create a table if it doesn't exist already. And keep the table up to date by updating rules if there are changes in the source data, adding new rules that don't exist in the table yet. Just like basically want to like do something like maintaining a master list of news articles, uh, where you can update any outdated information and add news articles that aren't already in the list. So what we need now is an explanation. So first of all, we go ahead and import libraries. So this part imports the analysis exception class to handle errors if the table already exists. So that's why we said from PySpark.sql.utils import analysis what's called exception. So we're using this to catch specific exceptions that arise during our Spark operation. Basically, you can think of this as preparing to handle any errors when we try to save our data to our database. The next thing we did, or next thing here you can see is our try block. And what's actually going on here is that we're going to be writing our data to the table. So here the program tries to save the clean data set, that's the df clean final, into a Delta Lake table. What's actually happening here is that the table name is defined as this Bing Lake CBL latest news. That's what we define the table name as. And the clean data frame df clean final is saved as a Delta table. So you can see save mode Delta in the database. So this will help us ensure that data frame is written in a Delta format which supports ACID transactions and efficient updates. So basically, it's like creating a master list of news articles in your database. If it doesn't exist, we create it here. So the exception block, the except block. So here we handle existing tables. So if a table exists, so from this code cell, if the table egg and down and downward, if the table exists, okay, let me just highlight where it is, and downward all the way to here. Yeah. So if the table exists in an analysis exception is raised basically, and the program proceeds to update it. So what's happening? A message is printed, table already exists, and we have a temporary view created from the clean dataset. So df clean final is the view VW definitely clean final is going to be a temporary view created from the clean data set. So basically, the temporary view allows us to use SQL commands for updating the target table. And I think we can think of this as creating a preview of the new data to compare it with the existing database. That's very cool. So we have the next step, the merging data step from the beginning all the way to here. Very interesting. So what's actually going on here? We're synchronizing tables. So actually we use Spark.sql. So basically if you want to write SQL in Spark, you have to use Spark.sql. But what's actually going on here? So the merge SQL command, which is the first, the merge SQL command synchronizes the data source or the source data source anyone. That's a temporary view with the target table. So what's the breakdown? Let's explain this a bit more. So let's go all the way to here. So we are matching rows on the on clause. If you go all the way to here, you see on source view dot URL equals target table dot URL. What's going on there is that rows are actually matched by the URL column. So this is a very important step in this, in this code and whatever. So rows are actually matched by the URL column, which unique URL basically identifies each news articles. So the URL acts as a primary key to ensure accurate matching. So to make sure anything that's been matched is accurate, we use the URL. So it acts as a primary key to ensure accurate matching. So you can think of it as matching articles based on their web address, aka URL. So let's go to the when matched. So that's from here all the way to here. Let's explain what's going on. So basically, if a row exists in both the source and the target tables, but has different details, let's say title, description, category, etc. Then what happens is that the row in the target table is updated. So basically, the conditions here, the conditions are checked row by row. What's going on in this workflow is that the conditions are checked row by row, ensuring updates only occur where values differ. Ensuring updates only occur, so this is only updated where there are different values. So basically, it checks for differences and updates only when needed. So when not match insert, what can I say about this? When not match insert, so if a row exists in the source but not in the target table, it's inserted in the target table. So this ensures that no data is lost and it keeps the database in sync with the source. So basically, news articles that aren't in the database are added. That's what's up. That's what's going on. Yeah. So I think this is a very efficient way to manage data synchronization and things like that. So actually, all this explanation, this code cell is basically what helps us go ahead and perform incremental load properly in our step-by-step end-to-end project. So what I'm going to do now is I'm just going to run this. So of course, our table is empty because we had deleted the table previously. So I'm going to run this. While it's running, I will create a table, a code cell below. And in the code cell below, I want to basically do what I did before. I don't know why I deleted it. I'm going to write an SQL code. SQL. So yeah, we'll write an SQL code that will help us, check what's actually going on in the table. So let's refresh the table, and you see that, what we want, which is table latest news, has been created, which is very fine. So now what I want to do is let's just see what's happening in the table. So select count all. So that's what we do. We did this before actually. Select count all. I select everything. I want to see how many rows. I think it was 51 before. It should still be 51 because this is actually we deleted the table basically before, so now it's basically exists for the first time now again. So it's gonna be 51, and what I plan to do actually is after you see that it's 51, I would rerun the code. So let's see the count. Let's see the count. It's running. Yeah, 51. So what I'm gonna do now So previously, before, I think with the append mode, which was not the best, of course, we when we run the code the second time with the append mode on, what happened was from 51, the number of rows or the row counts changed to 102. For in this situation now, going back, because I've properly configured the incremental load in our workflow now. So I'm going to run this again to cross-check whether we still have 51 or whether it's because I'm not going to the beginning like to the first row and running everything. I'm just running it from here. So it should still be 51 with this our exception handling and things like that. So let's run this, run it again. Table already exists. Okay, then it knows that. Okay, still running. Yeah. So let's run this. Okay. So you can see we have been able to do something beautiful. We have been able to do something awesome. So at this point in time, we have been able to properly configure incremental load in our Spark notebook for our project. So